Of course, it's not a shame if you could not answer this quiz question, because we only discussed the theory in this video. So what you first have to notice is that we look at income changes and we keep the prices fixed. And this is also why in this exercise it is given that the price of apples and bananas equal 2. So we're going to shift the budget constraint, but we're not changing the slope of the budget constraint, because in all that we do, the price of apples and bananas is fixed at 2. Moreover, we look at optimal consumption bundles. So the consumption bundles A, B, C, etc. that the consumer will consume in equilibrium. And we know that in equilibrium, it needs to hold that the marginal rate of substitution of this consumer is equal to the price ratio, unless we have a situation with perfect complements or perfect substitutes, but that's not the case because here we have a Cobb-Douglas function and an interior solution. So, getting to the answer, this is the answer. We know that the Cobb-Douglas utility function gives us a marginal rate of substitution of B over A. Given the prices of bananas and apples both being equal to 2, this has to equal 1 in equilibrium. So we know that in each optimal consumption bundle for the different income levels, independent of what that income exactly is, apples and bananas will be consumed in a ratio 1:1. And now we can plug this into the budget constraint. So we have the budget constraint, well, an apple and a banana each cost 2. So we have 2 times A plus 2 times B needs to equal our income, which is in this case denoted by Y. So we know, given that they are consumed in equal proportion in the optimal solution, we can replace the B with an A and we arrive at 4 times A is equal to Y. So it means that the relation between the optimal number of apples that we will consume and our income is given by income divided by 4. Whatever our income is, we will spend 1/4 of the income on apples. So, or I should state this differently, we will spend half of our income on apples, but given that a price of an apple is 2, if our income is 20, we can afford to buy 5 apples, or we will buy 5 apples in equilibrium. Okay, and this is the mathematical exposition of what we will do next, but I will start graphically. Income expansion paths and Engel curves. So we go back to our familiar indifference curves and budget constraints, and we fix the prices of both apples and bananas at 1 in this example. And we have a certain income level, and here again income level is denoted by I and not Y, and say that our income level initially is 200. Let's derive how many apples we would consume given this income level. So this is the budget constraint. The slope is a very neat -1 because the price of apples and bananas is both equal to 1. Here is an indifference curve. Looks like a Cobb-Douglas type of indifference curve, and the optimal consumption bundle is given by the blue dot. At this point, we can back out how many apples we consume and how many bananas. So we also have the relation between if the income is 200, how many apples will I consume in equilibrium. And that result can be plotted into the AI space, where we focus on apples and we get rid of the bananas in this graph, which frees up the y-axis for denoting the income level. And we have one dot. We know that if our income is 200, then our consumption of apples is equal to this amount over here. And know that on the x-axis I don't explicitly denote units, but you can think of anything. So here the intersection with the x-axis in the budget constraint should be at 200, because if we spend all our income on apples and the price of apples is 1, we can buy 200 apples. Now, what happens if our income increases to, say, 250? Then the budget constraint shifts outward and we can reach a higher indifference curve. So that might be this indifference curve. Both apples and bananas are considered to be normal goods, so we increase the consumption of both. But in our Engel curve below, we are only interested in what happens to the consumption of apples, and given an income of 250, our apple consumption increases to the level given. Now we can play around with this, further increase our income to 300, we get a new optimal bundle. At this new optimal bundle, we will still consume a bit more apples, a bit more bananas, and we get a third dot on the graph below. We can do this for 350, we get the fourth dot, and so on. And in the end, we can connect the dots in the top graph. That will give us the income expansion path. And then we can do something similar in the bottom graph, and that one will give us the Engel curve, the relation between income and the consumption of apples. So this is the graphical exposition of what in the quiz you did mathematically. Now, continuing a little bit, the Engel curve. So on the previous slide, I had an Engel curve at the bottom. Here we have two graphs that both will depict an Engel curve, because both have income on the y-axis and then here a good on the x-axis. And on the left panel, we have bus rides. And on the right hand, we have bottled water. So how does the consumption of bus rides change with income? And what the graph is going to show you is that a good can be normal at some level of incomes and can be inferior at other levels of income. So considering bus rides, the Engel curve may look as follows. So if you start with an income of 0, you cannot take any bus ride. So, but then if your income increases, your number of bus rides increases, you can buy bus tickets. So here it's a normal good. Your income increases and your consumption of bus rides increases. But then you have an inflection point. And if your income increases above the inflection point, you no longer increase your consumption of bus rides, but you start decreasing your consumption of bus rides again. Maybe because now you can afford to buy a car. So at that point, the bus rides become an inferior good. So we have that at point D, the inflection point, bus rides become inferior. And before that, at points A, B, and C, bus rides are a normal good. Now, bottled water. In the Netherlands, people don't drink a lot of bottled water because the tap water is so good and drinkable in the Netherlands. But in other countries, it's different. And for bottled water, the Engel curve may look something like this. So here, at all levels of income, bottled water is a normal good. So at all levels, if your income increases further, your consumption of bottled water will increase as well. Okay, a short intermezzo and some history. So in 1930, so 100 years ago more or less, Keynes wrote a short paper where he explored the economic possibilities of our grandchildren. And this is a famous article. And he saw the industrialization and the economic development, and he said, well, suppose that 100 years from now, we will be, in an economic sense, 8 times better off than we are today. And if you look back and you compare the welfare at the time of Keynes in the 1930s to the welfare that we have now, then in an economic sense, we are much better off. We can afford a lot of more stuff than the people at that time could. And then he said, I draw the conclusion that assuming no important wars, well, this is 1930, but some important wars happened after that, and no important increase in population, the economic problem, well, the population did increase, but still the economic problem is more or less solved because welfare has increased despite the increase in population and despite, for example, the Second World War. In Western societies, we are much better off than people were back then. So if then, what would then happen? And Keynes figured that if people are much more wealthy, then they might decide not to toil that much anymore and to reduce the number of hours they spend working. Because if you can earn sufficient money in 20 hours a week, why would you work 40 or 50 hours a week? Also because if you decrease your number of hours worked, you can increase your leisure time. And it's reasonable to assume that leisure is a normal good. If your income increases, you want to have more time for yourself. So if you become much more better off, why shouldn't you reduce the number of hours that you work? And then in the 1930s, this was not a reality, except for some shifts in society. So the wives of the men in the well-to-do classes, they already had a lot of time on their own. And he said, well, if I look at these people who have been deprived by the wealth of the traditional tasks and occupations, so the women in the well-to-do class, they didn't have to do all the homework, then he observed that they cannot find it sufficiently amusing when deprived of the spur of economic necessity to cook and clean and mend, yet are quite unable to find anything more amusing. So Keynes' opinion about these women was that they really did not find a good use of their spare time, their leisure time. So for those who sweat for the daily bread, leisure is a longed-for sweet until they get it. But, he continues, I feel sure that with a little more experience, if we get more experience in how to spend our spare time well, we will use this newfound bounty of nature quite differently from the way in which the rich use it today, and will map out for ourselves a plan of life quite otherwise than theirs. But humankind is been used to working. We have done that for ages. So we will continue to work some hours per week because we just need it for our mental well-being. But then after 3 days, so he talks of 3-hour shifts or 15-hour week, may put off the problem for a great while. So we need to work 15 hours a week in order to get some satisfaction and for our mental well-being, but then we can quit and we can use the remaining time to do nice things in life. Now, we're 90 years further and this has not happened. So many people have 2 days off nowadays, Saturday and Sunday, whereas in the 1930s people mostly also worked on Saturday. But apart from that, people still work about 40 hours a week. They work a lot of overtime, and with the home working, things did not really improve. If anything, people started to work more. So Keynes' prediction on how the time use would change because of this great increase in income has not come true. However, the message of Keynes and this idea that we should not work that much anymore is still often heard in the newspaper. And here's an example from a couple of years ago where Anna Coate also says, well, to reduce stress, we should reduce our working week to, say, 21 hours. I just want to give this to you to consider that if leisure is a normal good, so meaning if your income increases, you should have more of it, why do we still work that many hours given that our income is so much higher than that of people in the past? Okay, so now we will derive a demand curve and we will depart from how income changes affect our demand for goods, but we will now consider what happens if the price of a good changes. So demand curves, they are defined as the relation between quantity demanded and the price of a good. And to derive the demand curve, we of course need to know how a consumer responds to price changes. And we want to change one price and then see how that affects the demand by the consumers, keeping all other things the same. And this is the ceteris paribus assumption. We need to keep all other things constant. Now, if you want to empirically estimate demand functions, that is the challenge, because if the price of a good changes, sometimes that's, and most often, other things change as well. The price change may also be a response to the other conditions having changed. So in the empirical estimation of demand functions, this is really a difficult problem. In theory, it's easy because we can just assume it. So how to do it graphically? We're back to the apples and bananas, and we fix now the income. So in the previous section, we fixed the prices and we changed income. Now we fix income and we fix the price of the other good. So this is the ceteris paribus condition in action, and we are going to change the price of apples, the good that we consider. So for a certain price of apples, and we start with a price of 6, we can derive how many apples the person would consume given the other things like the price of bananas and income. So at a price of 6, if the person would spend his entire income on apples, he could buy 4 apples. And he may have an indifference curve of the following form, and we have an optimal consumption bundle, which gives us an optimal consumption of bananas and apples, but we're only interested in the apples here. And we will plot this combination in the AP space. So let's do that in the bottom graph with apples on the x-axis and the price of apples on the y-axis. And we now have one point of our demand curve, because we know that if the price of apples is 6, we will consume the quantity given by the blue dot. Now, of course, we can change the price of apples. So let's increase the price of apples to 8. Now, then the budget constraint will pivot inward. So if we would spend our entire income on apples, we can no longer afford 4 apples, but we can only afford 3 apples. So this is our new budget constraint at the higher prices. We're going to maximize our utility given this new budget constraint. We arrive at the indifference curve like the one over here. That's the one that is feasible. And our optimal consumption bundle is the blue dot. And in our bottom graph in AP space, this is the blue dot that is given. Now, if you further increase the price of apples to say 12, then we can, again, we have a new budget constraint. We have a different optimal consumption bundle that is feasible, and we have a lower quantity of apples that we will consume in equilibrium. And finally, we can increase the price to 24, and we have a fourth point on our demand curve. So if you now focus on the bottom graph, this is the one that will give the individual demand curve. And now we connect the dots in order to get it. And our demand function will look something like this. And we can see that if the price increases, then the consumption of apples will go down. So the price elasticity of demand is negative. Which brings us to the second quiz. Suppose that the utility function for apples and bananas is equal to A times B. And this one is very familiar from the first quiz, so we're very consistent here. Derive the demand curve for apples if the price of bananas is fixed at 2 and your income is fixed at 100. Good luck.